Hello guys and welcome back to my channel Cracking the Technical Interview. In this channel we disclose almost all the technical questions that are asked mostly in product-based company. My name is Anindo, working as technical recruiter at Oracle, and I am here to help you so that everyone can land their job in their dream company. So let's start the journey. Hello guys and welcome to another video tutorial series on linked list. And today we will be starting a new topic of linked list, that is solving the technical questions that comes during the interview. So if you have followed my previous video, you must be knowing that in my previous video tutorial I have given an introduction to linked list and also have covered the basic questions that you can experience during technical interview. For example, inserting a node, deleting a node, on all this stuff. So I highly recommend you to go through my previous video tutorials if you want to know the basic things about linked list. So today's topic is finding the middle element of the linked list. So I will be giving particularly two solutions to this problem. One is a basic solution, that is a brute force approach, which does not consider the space and the time complexity. And the second solution that I will be giving, that will be the optimal solution. So based on where you are approaching for the interview, you need to give the solution accordingly. For example, you are going for an interview to any product based company, then I will prefer if you give the optimized solution. So let's begin with understanding the problem with our whiteboard session. So there are three questions that are most important for the technical interview that can be solved with this particular approach. So the number one will be a straightforward, that is finding the middle element of the linked list. Number two, delete the middle element from the linked list in single iteration. And number three, insert a node in the middle element of the linked list in single iteration. So whenever the interviewer is asking a question mentioning that is a single iteration, that means he is looking for an optimized solution. So in that case, you must give my second solution to this question. But before jumping into the second solution, let's understand this topic of how we can do or how we can solve using brute force approach. So let's start. So here you can see the question is asking to find the middle element of the linked list. And the most easiest way to find the middle element is to calculate the total number of node that is present on the linked list and then divide it by half. So here if we count the number of node present over here, that is 1, 2, 3, 4, 5. So dividing the total number of node present on the linked list by 2 will give you the first solution. So in this example, we have 5 nodes, and if we divide that by 2, we will get the solution. And take the seal of that, that is 3. That is the third node is the middle node of our linked list. So here 1, 2, 3. So this is the middle node of our linked list. So this is a pretty easy solution to this question. So let's see how to solve this question using Java code. So let's write a Java function to solve this problem. So I will name this method as find middle. Since we will be returning the number at the middle, so I am returning int over here. And here we will pass a single parameter, that is the head of the linked list. The first thing what we will do, for safety purpose, I will create a pointer ptr over here that will point to the first node, that is the head of the linked list. So let me create the pointer. That will point to the head of the element. Now the next thing what we'll do, we will count the total number of nodes over here. So I will write a while loop. So until the pointer reaches the end of the linked list, we will keep on iterating and count the number of element into it. For that, I will create a counter variable. So here I will increase the counter and move the pointer. So when the pointer reaches the last node of the linked list over here, at that time the value of counter is 5. Now what we'll do, we'll try to find the middle element, which will give us the value as 3. So simple, right? We already got the position of the middle element. Now what we need to do, we need to set the pointer again back to head so that we can start the loop again from the front, and then we will just iterate for this many number of times, means 3 times forward, so that we can reach the middle element. So here I will write a while or a for loop. So here I am starting a for loop which will loop for only 3 times over here. So for those 3 times I will just keep on moving the pointer forward. So at the end of this for loop, our pointer is already at the middle element over here. At the end, we just need to return the value of this pointer. Thus, it will return the middle of the linked list. So let me explain what I did over here one more time. So here what I did is, like, for the first time we have created a pointer, and our pointer keep on moving forward until I reaches the last element. And while it was moving forward, I was keeping a note of the count variable, that is the total number of node that I have encountered. So here the count is 1, here the count is 2, here 3, here 4, and so on. So here at the end I got the total count value as 5. Now here I manually divided it by 2 so that I can get the position of the middle element, that is 3. Now our job is quite simple. Since the pointer is over here right now at the last element, we need to reinitialize the pointer again back to head. So we are again starting the loop from here, and we will keep this pointer moving in the forward direction for 3 times. Since we know that our middle element is located 3 places forward away from the head, so we will keep moving this pointer forward for 3 times, 1, 2 and 3, and thus at the end of this iteration, this for loop, over here we reaches the middle element. So here we reaches the middle element and we are sending this value as a return type. So here you can see we have managed to search the middle element of the linked list. So from here you can expect 2 more questions, like you have to insert one more node over here or to delete this element from here. So for insertion and the deletion of the node, I will highly recommend you to go through my previous video tutorial where I have explained it in detail. So this was our solution 1, that is the brute force method, because iterating this 2 times, one for counting the loop, second for half of the loop. So this approach is not very much acceptable during the interview process if you are going for any product based company, because at that time interviewer will expect an optimized solution. For that we will move to our solution 2, that is an optimized one. So let's move to the next solution. So let's start with the second solution and the optimized solution of this problem. So before jumping into the coding section for this solution, let's understand the solution of it in the whiteboard session. So as I have already told you that when the interviewer is asking a question with single iteration, then always remember he is asking for an optimal solution. So in our previous solution, what we did is like we iterated this linked list twice to get the middle element. But this time we will iterate this linked list for only once to get the middle element. So how we will do it? Let's see. So this approach is quite simple and effective, and with this approach you can solve many problems on linked lists that deals with single iteration. So let's understand this solution. So for solving this problem we will be using two pointers, one called as fast pointer, one as slow pointer. So as the name says, the first pointer will move and iterate the linked list faster than the slow pointer. So what we'll do over here is like, for the first time we will initialize both the first and the slow pointer to head, that is the first element of our linked list. Now what we'll do, using the first pointer we will keep on moving forward until and unless each reaches the null element. But the trick is like, instead of moving one step at a time, the first pointer will move two nodes at a time and the slow pointer will move one step at a time. What does it mean? Is like, for the first time both the slow and the first pointer will be pointing over here. On the next iteration, the first pointer will move two steps forward, means over here, and the slow pointer will move only one step. So on second iteration, the first pointer will move two steps forward again. So it will point to this node, and the slow pointer will be over here. The first pointer will again try to move two steps forward, but it will see that it have reached the null element, that is the end of the linked list. Thus it will stop iterating. So in this scenario, if you can see, the first pointer reaches the end of the linked list and the slower pointers, since it is going at the half speed of the first pointer, it is pointing to the middle element of the linked list. So here you can see that only with one iteration we have found the middle of the linked list. So let's understand the coding of it. So what we will do, we will simply write a while loop using the first pointer. So until the first pointer reaches the null, it will move two steps forward. So here you can see the first pointer is moving two steps at a time, whereas the slow pointer is moving only one step. Now at the end of this iteration means we have encountered the null value, the end of the linked list. Our slow pointer is standing at the middle node, and thus we will return the value of the slow pointer, and hence we have found the middle node of the linked list. So this is pretty much the optimal solution of this problem, because we are using only a single iteration, hence it is quite optimized on time complexity as well as on space complexity. So let's write the solution in Java. I will name the method as find middle element. And just like before, here we will also pass the head of the linked list. So what we will do, first we will create two pointers, the first and the slow, which will point to the head. Similarly, we will create one more pointer that will point to the head element. Now we will write the while loop to move it forward. So here we are taking two steps forward, and the slow pointer one step at a time, and at the end we will return the value of the slow pointer. So I hope this solution is pretty much clear and easy to implement. And this handling of two pointers, the first and the slow pointer, is quite tricky, and this gives a number of solutions to many problems. So please try to understand the way it is working, because this will provide an optimal solution to many of our problems in linked list. So let's do a dry run of it. So for the first time, we have the slow pointer and the first pointer both pointing to the head element, that is the first node of our linked list. Then we will check whether the first pointer is pointing to a null value or not. If not, it will move two steps forward. So over here, it will move two steps forward, and the slow pointer will move one step forward. For the next time, it will again check whether the next is null or not, and it will move two steps forward, and the slow pointer will move one step forward. So over here you can see I have taken a pretty good condition where the number of nodes is odd and it will satisfy the condition. But just to provide a better solution to this problem, also check whether the first dot next is not equal to null. Otherwise it might can give a null pointer exception at some point. So while running the program on Eclipse, just keep check on this condition one more time. So this is pretty much the optimized solution to this problem, and I would highly recommend you to give this optimized solution during interview if you are appearing for any product-based company. So also before going to any interview, don't forget to practice these two problems, because these also deals with the similar type of approach. So it's better you just practice these two also, so that you get a good hold of this type of approaches. And do let me know in the comment section below if you stuck in understanding any of the solution to this problem. So let's move to the next question of our linked list, that is finding the nth node from the end. There also I will be giving two solutions. One is the brute force approach and second is the optimized solution. See you in my next video. Thank you.